Hi, I'm Colin Walls and I'm here again to talk about embedded software. Today I want to talk about optimization. Now, embedded developers tend to be very interested in controlling the exact nature of the code in their target system. They often worry about compiler optimization, and is the code going to be big but fast, or small and slow, or some combination between those. They want to have control over it. But that isn't exactly what I'm going to talk about today. I want to talk about data optimization. Now, this is not something which is considered in quite so much detail, but in its own way is just as important. So let's take a very simple example. Here we have a declaration of two arrays, as alpha and beta. They're both char arrays, so each element occupies a single byte. And as you can see, alpha has 3 elements and beta has 5. So how would these be stored in memory on a 32-bit device? Well, there's broadly 2 ways of doing it. The first, and probably default way of doing it, would be like this. So alpha would occupy 3 bytes of a word. Beta will occupy 4 bytes of one word and 1 byte of the following one. But the key thing being it starts on a word boundary. This means that the word that alpha occupies has a wasted byte, and actually the second word that beta occupies has 3 wasted bytes. Now, that waste means the arrays are taking up more space in memory than they strictly need to, but most processors access memory on a word basis, and therefore this can speed up access. So data laid out this way will be fast. The alternative would be to put the data in memory this way. So simply store the bytes of these 2 arrays in consecutive bytes of memory. So alpha would still occupy the first 3 bytes of a word. Beta would occupy the remaining byte of that word and all 4 bytes of the word following. In this case, there is no waste at all. Every byte is used. However, the access time would be increased. But maybe that's the trade-off you want. You need the choice. So how do you exercise this choice? Generally, there is simply a switch on the compiler. You simply say whether you want data packed, which means no waste, or unpacked, which means faster access. One step beyond this, it's very common to have 2 extra keywords in the C language extensions supported by many compilers, and these keywords are packed and unpacked. The idea of them is to specify the packing for a specific object, for a specific array. This will override any settings on the compiler. So you set the compiler to enable the default packing of unpacking, and then you use these 2 keywords as appropriate if you want to specify on an individual object whether you want it to be compressed into memory and a bit slow, or wasteful of memory slightly and faster. So that's the idea of data optimization, and this applies not just to arrays but to structures and so forth as well, which can be very wasteful and or very efficient depending how they're laid out in memory. So that's it for today. I hope they find this insight useful and will apply this in your applications in the future. I'll be back again soon with some more things to say about embedded software, but with that I'll say bye for now.